To our lesson today. We're going to be talking a little bit about paragraph proof and a little bit about geometric probability. Let me just open up my page here and we'll get started. My apologies for not being there today. Here's our learning target. Students will be able to write a paragraph proof and solve simple counting probability. Of a little bit of review problems. Here's our first one. Let's go ahead and hit pause and we'll go over these answers. Okay. The line CD is a segment bisector because it divides segment AB into two congruent parts. Point C we would call a midpoint. And I just want to take a minute to review the difference here between segment addition postulate and segment bisector. Segment addition postulate here on this left side, we have 2x as part of the segment and 4x plus 3 as another part of the segment, and the entire segment equals 21. So to set up an equation to solve for x, we might add these two segments together, set the total equal to 21. For segment bisector, though, we have a bisector or a midpoint that divides the segment into two congruent parts. So here we have 7x on the left side, 4x plus 12 on the right side, and in this one we're not adding and setting equal to the total as we did with the segment addition postulate. Instead we're going to set 7x equal to 4x plus 12 since a bisector divides a segment into two equal parts. As we have seen with segments, we also know the same to be true with angles. So here on the left side we have the angle addition postulate, and on the right side we have an angle bisector. In angle addition postulate, we know that one part of this angle is marked as 3x, another part is marked as x plus 6, and the total is 66. So we'd have 3x plus x plus 6 equaling 66. Whereas on the right side here, we would just simply set 4x equal to x plus 15 since the ray AC is a bisector of angle BAD. So when you're looking at problems like this, look to see, are you using segment or angle addition postulate, or do we have a bisector? Okay, I am going to post some of these homework problems and some of these homework answers on Canvas for you guys to look over, and hopefully you can work together to figure out why the answers are what they are. And I want to jump right into our basic elements of proof today. Okay, so the basic idea of proof is this idea of chain logic. We have a conditional statement, if A, then B, tied with another conditional statement, if B, then C, and then if C, then D, and if D, then E, and et cetera, et cetera. We call this a chain of logic because we're able to chain together the conclusion of one statement with the hypothesis of the other, So for example, if part A is a statement that it is Wednesday, and B, there is school, C, pack a lunch, D, make a sandwich, and E, eat bread, then this chain of logic might read, if it is Wednesday, then there is school. If there is school, then I will pack a lunch. If I pack a lunch, then I will make a sandwich. And if I make a sandwich, I will eat bread. So once you have this chain of logic, if you have the hypothesis of the first statement, you can then conclude the concluding statement of the last. Therefore, if it is Wednesday, I'm going to eat bread. Now, I don't know if you're going to eat bread on every Wednesday, so there might not be a perfect chain of logic here, but there is when we do geometric proofs. So let's just jump right in. Okay. Theorems are statements that can be proven using a deductive structure. You must prove theorems by using conclusions previously assumed or proved. And we'll talk a little bit more about this as we move forward. But remember that you cannot use a theorem to prove itself. So if you're trying to prove a theorem, you can't use the theorem itself as a reason. So conditional statements are any statements that can be written in if-then form. For example, if you live in Naperville, then you live in Illinois. Or if today is Wednesday, then tomorrow is Thursday. Any of those statements in if-then form are conditional. The condition being the if part is happening, the then part will then happen. The if part is called the hypothesis, the then part is called the conclusion. Here's another example. If today is Friday, then I will wear red. The red part here, the words between the if and the then, today is Friday, we call the hypothesis. The blue part, I will wear red, is the conclusion. So the conditional statement is really that basic element of our proof structure. To be allowed to use any statement, the hypothesis must have been met at some point. So here are some different places where the hypothesis might have been met. It might be a given statement that you have to start the proof. It might be assumed from diagram. We've talked a little bit about that. Or it might be a conclusion from a previous statement, and there's your chain of logic that we've been talking about. You're going to see this in all kinds of different proofs moving forward. But remember that once that hypothesis is met, the statement can be said and the conclusion becomes true. And this is deductive logic. The conclusion isn't just thought to be true, it's a lock. It's gonna be true. If today is in fact Wednesday, then tomorrow will in fact be Thursday. And that Thursday is a fact that can't be undone. So we're going to do a lot of different proofs in here. We'll do some two-column proofs. But I can tell you that paragraph proofs are much more prominent, especially these days. And so you'll need to write a paragraph proof just as much as you'll be writing a two-column proof. So the only difference between a paragraph proof and a two-column proof is that a paragraph proof just ties together the statements and reasons. I like to call that tying together connector words. Connector words such as so or thus, therefore, or also, or then, or because. You remember that cable company commercial? You'll see some of these connector words as we move forward. So here's a simple paragraph proof that we saw from that commercial. Now we know that this isn't a real proof because the logic doesn't hold, but it does show that chain of logic. So let's just read this. If a cable company keeps you on hold, then you get angry because, and there's your connector word, because it's frustrating to be kept on hold. Thus, here's another connector word. Thus, if you get angry, then you blow off steam. Why? Because it's not good to hold in anger. Here's another connector word. Therefore, if you blow off steam, then accidents happen because blowing off steam creates accidents. And when you blow off steam, then you get an eye patch because due to all accidents are eye related. Now, of course, that's silly, but you get the idea that these connector words tie your statements together. Okay. So let's see an example of a real geometric proof. All right. And these are some different proofs that you'll be writing going forward. We do have a test coming up in a couple of days, and you'll be required to write a proof on one of these tests using some of the basic elements we've been talking about. So here's a simple proof, and let me just kind of make the window a little bit more readable here. There we go. Okay, so here we have some given information. We know from given information that angle ADB is 40 degrees. I'll just highlight it there. And BDC is also 40 degrees. We're going to prove that this ray is an angle bisector. Okay. All right, so it looks like I'm going to have a second cut on this. So we're going to continue this in a different clip. We'll see in just a second.